I would welcome everybody. We're going to have a little talk about observing with optical filters, not imaging with optical filters. Those of you who are interested in knowing about imaging with filters need to go to the imaging group because there's a whole different world there for filters. But for tonight's discussion, I saw a post on the RAC Academy list a while back about it, and I realized that there's so many filters to choose from, so many different ways to use them, that maybe it needed to have a little talk of its own. So, yeah. So, if I say something that doesn't make sense to someone, we're all coming from slightly different experience levels. So if I say something that doesn't make sense, please speak up and we'll clarify if we can. Filters for visual use, the reason you would use those would be to enhance your view. So generally speaking, you're increasing contrast with one of these low contrast objects. And the way they work is that they pass certain portions of light and block others. How they do that is a fairly interesting process. I'm not familiar with the way color filters are made, but we do have people present who would know. There are standardized color ratings so that when you say, I want a color filter red, whatever, other people know exactly what you're talking about. So I don't know how those are produced, but I do know about the deep sky filters. For example, I have one here. You can see it's shiny and it's fairly short and it's about the size of an eyepiece. The way these things are made is you have optically flat glass and you deposit various layers of a material that is an interference, produces interference, so that certain light bandwidths are passed and certain ones are not. So the production of these things is, I think, fairly meticulous. So you can get all grades of these kinds of filters. Ones that are very carefully made and pass very specific portions of light, and others that are less carefully made and have a wider band pass, if you will. This filter, pardon me, is 1¼ inches in diameter. They also make these in 2-inch diameter. And the reason why is so that you can thread it. If I can get the thread started. So you screw it into the bottom of your eyepiece, and now it's fixed, and you would drop that down into your focuser. So once you've put the eyepiece into the focuser with the filter screwed on, you'll tighten the little set screw and everything will be very secure. One thing about these filters that I have learned is that is optical glass, and the coatings are somewhat sensitive. And so fingerprints and dust and so forth are a bad thing. I clean my filters rarely. I use something like a lens brush that you might get at a camera store to brush dirt off or blow it off. I've gotten fingerprints on filters before, and I'm trying to remember how I cleaned it. I may have cleaned it with either distilled water and a Q-tip or ROR, R-O-R, lens cleaner and a Q-tip. I would clean it very much like I would clean an eyepiece. But again, those coatings do all the work, and they are somewhat fragile, so be careful with them. The color filters, Those would be optically flat glass too, right, Jim?
Yeah, they should be if they're good quality.
Yeah. And I would think to clean those, you would use something like a lens cleaner also.
Hey, Phyllis,
Um,
this is Doug. When you're
yeah.
using ROR to clean with, what are you doing? Are you just putting a little ROR onto a Q-tip and just going over the surface? And then how do you clean the ROR back off?
The process I've come across is ROR, and you don't use the Q-tip very long on the optical surface, throw it away. Jim taught me that a whole box of Kleenexes and or Q-tips is good. They're cheap, just throw them away. So the other substance I use is acetone. And once you've really got the surface clean, you can breathe on it. And when the mist just dissipates right away and evenly, it's clean. So we did I think we did an eyepiece cleaning clinic some years ago. Maybe we can do another one in the spring.
I think we did that a very long time ago. We should probably, I don't think we recorded that one. So
That was before the days of recording.
Yeah.
That long ago.
Yeah, we should do that again. All right. So anyway, once we're filtering light, if you think of the light as a spectrum, there are certain portions of that light that are emitted by street lights and neighbors' lights and so on. And it would be really great to be able to get rid of that, but keep the light from the celestial object. So if we can design a filter that can get rid of those bad light effects, but pass the good light effects, it would be really good. So it turns out that different types of objects emit or reflect light differently. And this is a physics thing. So if we have to get detailed, I'll ask Steve to explain. But my favorite things to look at are hydrogen alpha emission nebulae. I really enjoy looking at those. And it turns out that filters are really good for that. I enjoy looking at galaxies, but that's a pretty broad spectrum of light coming through from a galaxy. So filters aren't as much help with that. My favorite objects would be planetary nebulae, and those emit in hydrogen alpha and oxygen 3. Again, we're in luck because the optical filters can help with that. Now, back in the good old days, when I first got my filters, most of our street lights were sodium vapor lamps. They were high pressure or low pressure sodium vapor. So that was really not so hard to get around because these optical filters could block out the fairly narrow emission of those sodium lamps. Now we have these wonderful LED lights, and they broadcast this giant spectrum. And so it's harder to block that. It turns out with the LED lights, those things can be made with filtering in them. I don't know that I've seen that in the United States, but I'm aware that they can be made. The bad effect I think that we're having is that the LED streetlights or any kind of lighting is so much less expensive to operate. And now property owners are thinking, well, I can afford to have lots more lights now. So our problem has gotten worse. And I'm trying to remember, I've seen statistics, especially in Europe, about the change before the LED street lighting was out there and now. And it's so much more lighting. People really have jumped on the let's turn on more lights bandwagon. That makes the work for the filter much more difficult unless you're in an area that isn't lit by LED lights, or perhaps that they have filters. So with that in mind, we can use filters to help reduce the sky glow, the light pollution. But the LED lights are making that job more difficult. So I would just warn you of that. Bummer. If you look at the emission curve, various different kinds of lighting. So please tell me if this isn't clear for you, but if you look at the light spectrum in nanometers, not angstroms, but nanometers, you see a peak. Can you see my mouse? Yeah. You can see a peak just below 600, and that was the good old sodium, the low pressure sodium vapor lamps. So those were the ones that were in very common use, I don't know, into the 90s, maybe the 2000 era. There were some technical improvements. I hope I don't have a lighting engineer present. At any rate, Cree over in Durham came up with these LED lights, and they have exploded in use. And if you see the green curve and the blue curve, you can see that the neutral LED, I'm trying to think what is the difference between the green and the blue. They really take up big pieces of real estate down in the 450 region. And I think hydrogen alpha is at 656. Oxygen 3 is going to be, hydrogen beta is going to be around 450. So that is a wavelength we're interested in, and it's being stepped on squarely by these LED lights. The cool LED, I'm going to guess those are the real blue looking LED lights like we have near my home in Cary. I can maybe
the neutral LEDs are considered broad spectrum, but they're not that much different from the cool LEDs. So because I had blue LEDs in my flat field box for my imaging rig, and I had to change it to neutral LEDs to get a better flat field coverage. I don't know why. I don't understand what made the difference, but when I swapped out those LEDs, it worked a lot better. And I was told that neutral means it's a broader spectrum and it's more neutral. It's more centered on the visible spectrum.
I'm going to say 2 to 3 years ago, the switch out came near me. There is a stretch of Cary Parkway near my home, and it used to have low pressure sodium lights. It was very orange in color, and we could observe at home with some trouble, but we could do it. 2 or 3 years ago, they swapped them out for these really blue looking LEDs, and they were bright, really bright, to the point where the glare coming down the hill into this Cary Parkway area, they would be shining in your eyes, and it was blinding to me. I had to drive at night like this. It was ridiculous. And I think that we're seeing some effect of that at our house when we observe. I do think things are worse, but I don't know that stretch of lights is to blame. I suspect that the parking lot lights at Target are more to blame. But this spectral graph gives you a pretty good idea of the width of the bandpass with the LED versus the low pressure. Low pressure sodium was so much easier to deal with, and not so with the LED lighting. It's just so much wider. I think it's brighter. Maybe that's just me, but it's harder to deal with. So as we go to look at the few types of filters that I can think of for visual use. The first one would be the solar filters and the lunar filters. Does everybody here realize that you do not look at the sun without a proper solar filter, a specially made solar filter? Everybody have that? Yeah, yeah, good. You can buy solar filters in white light, a simple mylar or glass filter. They're not super expensive. When you move to the more narrow band solar filters, they get pricey. I've got a hydrogen alpha filter made by Daystar, and it's one of the Quark line of filters. And those things are going for $1,000 now. But the reason it worked for me was that the single package, the filter with the Barlow inside of the unit, I could put it into a telescope we had in the garage and we're not using. And I could put all of that on a tripod that Mark built that we were not using. So it was a perfect fit for me. Other people are so into solar observing that they buy new filters and all the equipment. And boy, I can tell you there's some people in our club right now making some incredible pictures of the sun. I think Steve Christensen is one of them. Solar filters, they're only good on the sun. That's the only thing you can use them on. But boy, do they do the job. The other thing would be moon filters, lunar filters. I do not have one of these. There are filters specifically made to observe the moon. And I think people do use neutral density filters with the moon. I have not done that. You would have to make sure that the threads, this part would be the correct diameter and the correct threading to go into your eyepiece. So people use lunar filters. I do not, sorry. Planetary filters is the next step, where if you're really interested in planetary observing, you will learn that there are some of these color filters that provide a tiny bit of contrast enhancement for different features on different planets. So the idea is you either buy the one or two filters that you really want to use on your favorite planet, or maybe you buy a set of filters to use when observing a couple of planets. The ones that I have tried were the light blue filter on Jupiter, the light red on Mars, and the violet one on Venus. I've never seen much difference with the Venus, but people use these worldwide, so I'm sure that there is some effect that is beneficial. These are minute contrast boosts. You have to become a very educated observer to see the change. But color filters for planetary use is a pretty big thing. I don't think I know of anybody in our club who uses these a lot. Don Morris may have, but he has passed away, so we can't really consult him. I would say if you have an opportunity to view a planet and observe through someone's filter, that would be a really good way for you to decide whether that kind of thing would be useful to you. So
I can interject just for, I agree with you. These filters are always sold with eyepiece kits, and as add-on kits to a lot of the telescopes. But for the most part, you really don't use them very much until you get around near opposition, where the planet is biggest and brightest. And so, yeah, and like you've already said, I've used green and blue on Mars and gotten some pretty good results. Red is also kind of good if you want to but the problem is Mars is so red that it just kind of wipes it out. But definitely have gotten good results with blue and green. But yeah, for the most part, my filters just sit around in my eyepiece case, rattling around. So I personally think that, yeah, it's not to me, it's not a great investment. Most of us are looking at deep sky, and as you've already mentioned, you'd want to do something that's got more of a wide range, like H alpha, O3, O2. um, so yeah.
Yeah, you have to become a pretty experienced planet observer, I think, to get real value out of these.
Mhm.
But they're pretty common. They're out there. You can get them used, that's for sure.
I have noticed that there is a slight difference between the labeling of a lunar filter.
Oh, yeah.
And sometimes people will sell you a neutral density filter and call it a lunar filter. I personally use neutral density filters, and I find them to perform better. There's less coloring, on the moon. So for visual, I would definitely recommend a neutral density filter.
Did you have any problems getting the right threads for your eyepiece?
No, mine seemed to work out pretty well.
Good.
Yeah.
I'm not experienced with that particular question, so I don't know.
You can buy a neutral density filter for 1.5 inches.
Yeah, you can even get them for 2. I have a
Yeah, you can get. I have one
1.25.
for my 2-inch.
I would add one more thing about planetary filters. Some of the online astronomy dealers have good information on their websites about planet filters, which ones are best for which feature on which planet. So if you think you want to go this way, I can't think of someone to point you to in the club who's really keen on using these. So it might be best to consult an online source, or wait until the next slide. Deep sky filters. Now we're getting into something I'm experienced with. I think I generally see 3 or 4 categories of these. And I'll go in order from the widest bandpass, the least effect, to the smallest bandpass and the most strong effect. By that, I mean that, for example, the first category, a broadband filter, which is intended to just knock down light pollution. I have one that I've had for some years. It's called a deep sky filter made by Lumicon. So I've used it on galaxies, and well, it didn't do that much there. And it just didn't do much on anything I used until I looked at Comet Halley with it. And it really did a great job with that. Why? I still don't know. Oh my. Do any of you have any positive experiences with a broadband light pollution filter, especially from observing in town, maybe?
Well,
Not really.
I will comment on that because I thought they were worthless. This is one, but I don't know if you can get the angle, but if you just look at it, it almost looks yellow-green because it's bouncing the yellow-green light off of it and transmitting the other colors. And I didn't understand it. I thought that it was designed to help you in the city knock down some of the glow.
Mm-hmm.
But what I have found recently, since I've tried to use it a little more out at Howell Woods, it's really kind of meant to knock down sky glow. It's sometimes it's called a sky glow filter. I think it says so right there.
Right.
And what it does is just slightly darkens the background so that if there is a nebulous area there, you can pick it up more easily. So in fact, I was using it totally wrong.
Well, it sounds like operator error got me also.
Yeah, if tried out someplace, if you need just a little help, a little boost, seems like out in the country, it worked really well. I was able to see the Owl Nebula fairly well with it, and it didn't seem to look any brighter in any of the other filters I tried.
Yeah.
And usually you can get these less expensively because nobody uses them and they sell them.
Well, I don't think they're as hard to make either.
Probably not.
I don't think they have to be quite as fastidious with the coatings and the interference pattern with the broader band filters. So,
Well, just don't expect them
you
to
think
help you
about it,
in
that's-
Cary or Raleigh. You have to
Yeah.
get out darker.
okay,
That's kind of, it makes sense that they're easier to make because they don't block as much. I mean, that's one of the things that makes a narrowband filter expensive is how narrow the bandpass is. And the more narrow you make the bandpass, the higher the price tag for the filter.
yeah,
And it's doing a better job of excluding all that light you don't want and only allowing through the specific wavelength.
yeah.
So, I mean, imagers for a long time have complained about those broadbands that they cut down more signal than they're worth if you're doing imaging.
Yeah,
And
well, it's the same. It's
I bought one of those from I've forgotten the name of the guy, the website, the Japanese website, but it was a real popular broadband filter. And I tried it and it cut down on so much signal. It was almost, I had to double my exposure time to focus.
I
If
believe.
that tells you anything. And looking through an eyepiece with it was impossible. You couldn't see anything.
yeah, but now that was a photographic filter, wasn't it, Steve? Or
Well,
was it
they
used-
said it could be used for visual too, but I don't know how you could do it because it was so dense.
yeah.
I tried it. I mean, I tried using it with my LX200. I tried using it with my Star Bridge or my Light Bridge. And I mean, I could look at the moon with it. It actually worked pretty good with the moon. It did a good job of cutting down on the brightness, but anything deep sky, it was kind of a waste of time unless it was a real bright star.
Well, the effect of what you're discussing, I will get into on the next slide.
Well, Phyllis, before we leave, the other thing to understand if you're new is the broadband filter won't help you on anything that's just natural light, like a galaxy. It's just going to push the galaxy down darker as well.
Right.
It will let through a little more of the nebulous stuff. So that's about the only place. And I think that's why I decided not to use it years ago, because I expected when I put it on that I would see galaxies brighter and nebulas brighter, and I didn't.
No,
So you
If you
have
go
to
to
figure
these-
out what it will do before you'll get it to work right.
You can go to these different websites and you can look at the wavelength analysis of the bandpass through the filter, and you
Yeah.
can see where they created layers of coatings to exclude specific sections of wavelength and let everything else through, in the idea that they're trying to intercept the most damaging of the wavelengths of light and allow through as much as you can without allowing any of that really bright sky glow through. You can actually see the different wavelengths plotted, like the plot that Phyllis had on the previous slide. And you can look at all those and decide if it's going to, I mean, you can look at the graph and tell whether it's going to show you what you want to see. If
Oh,
you're
yeah,
looking
but
at
you
a
have to learn-
hydrogen alpha object and it blocks a bunch of hydrogen alpha, it's not going to do you any good.
but you have to learn which kinds of objects emit what kind of light. And
Right.
that's where the rest of this slide goes.
Yeah.
The second category is a ultra high contrast. And I think most manufacturers use that terminology, UHC. And it passes the hydrogen beta emission line and the oxygen 3 emission line. I've got one that was made years ago by Lumicon, and the labeling, by the way, I probably had this one maybe 35 years, and I still use it. But it's so old that the statistics on the back are handwritten. It permits the 2 different lines of oxygen 3 and 1 line of hydrogen beta. So it's permitting over 90% at those specific wavelengths and blocking the rest. So if I look at something that I know emits light and oxygen 3, then this is a good possibility to use to be able to see that light and not the sky glow. Does that make sense? Yeah. It turns out with the UHC filters, I think right now Teleview makes an excellent one, and so does Lumicon. I'm not as familiar with some of the other makers, but just because this one works well for me doesn't mean that it will work well for you, and it doesn't mean that it won't. So I would say the best thing you can do is to try filters that other people have in your telescope with your eyes to see how it works, because they're going to work differently on different optical systems, and they're definitely going to work differently for different eyeballs. Now, we are splitting hairs here. It could make a difference to all of us here, but it could make a super big difference to me. But it could be that that's how I've learned to use the filter. In other words, I've educated myself what to look at and understand what I'm seeing through this filter as compared to not. And I'll explain the technique I use for that. But the important thing I'm trying to say is that, generally speaking, the broadband filter doesn't filter out a lot of light, specific wavelengths. The UHC blocks out most light except for a few bandwidths at oxygen 3 and hydrogen beta. The oxygen 3 filter blocks out the doubly ionized oxygen. It permits those, and it's really good for using on planetary nebulae and supernova remnants. So you're getting a lot less light with the oxygen 3 than with the UHC. And then the final one I see is hydrogen beta. The hydrogen beta filter lets very, very little light through. It is a very specific specialty filter, perhaps for the Horsehead Nebula or the California Nebula, because it's those specific wavelengths of light that those objects emit. They're not as commonly seen as the oxygen 3 or the UHC bandwidths. I use the UHC on most nebulae. I use the oxygen 3 with my bigger scope on planetaries, and it does a beautiful job. But frankly, my 8-inch telescope doesn't bring enough light to the eyepiece to then add an oxygen 3 filter on top. It blackens the view too much, and the view suffers. So there is a trade-off here. If you've got a small scope and you put a really strong filter on it, you're going to knock all the light out. You'll need less filter or maybe even no filter. It depends on the aperture of telescope you're using. So, 2 observing techniques. And I know that's why the new observers are here. Pardon. What can we do to make our views look better? Well, we already covered the lunar and the solar, and we covered the planetary. Those are real nuanced views with the planetary, and with the lunar, I frankly don't have enough expertise to really offer much guidance there. But the solar filters are terrific. Maybe I just have a good combination of equipment, but it's really quite a good effect. You can do some very good, meaningful observing. But when we get down to deep sky filters, like Jim said, if you go out to a dark place, a really dark place, you can begin to get a little bit more value out of these deep sky filters. Probably if you do or do not have a filter, I would say that the very first observing technique to improve views is to put a towel or a drape or something dark over your head and the eyepiece so that no stray light is coming in. This is super valuable in my front yard when all the neighbors' lights are on. If I put something over my head, the only real drawback there is that we can get too much humidity under that towel and the eyepiece steams up. So that's something I have to deal with. But if I'm blocking all the ambient light out, then I can really concentrate on the eyepiece and see whatever there is that I might see. I can put in a filter that will help to cut down sky glow. Here again, if I'm in the city, putting that drape or towel, I actually use an old towel, but if I put the towel over my head and the eyepiece with the filter in it, I get pretty good results depending on what I'm looking at. I tend to look at nebulae of some sort. These filters aren't going to help you with like a globular cluster. They're not going to help with that. They're not going to help you with an open cluster or a galaxy. They're really not. When I'm using a deep sky filter on a nebula, let's say I'm looking at the Great Orion Nebula. I'll use a UHC filter for that viewing. I'll put the towel over my head, and you have to let your vision attune to the darkness under the towel, and you will realize that you're seeing more in very light gradations of contrast, at which point you realize you're seeing more structure in that nebula. And that's what the filter is for, in my opinion, is allowing you to see what little there is there. It's really a nuanced thing. Another thing I do, and I've been told by more than one person not to do this, but I do it. I blink a filter over the eyepiece. And I especially do this with the oxygen 3 filter when I'm looking at planetary nebulae. Let's suppose you're looking at a planetary that's very small. Many of them are stellar. They're described as stellar. So I'll have my eyepiece, and I will look through the eyepiece at whatever power it is. And I'll pull my head away, and I'll take my O3 filter, oxygen 3, and I will balance it carefully on the flat top eyepiece and look again. So then I can blink in and out if I want. I know when I do this that the thing that stays brightest is probably the planetary nebula, because the oxygen 3 bands are passing through the filter, and the continuous band of the starlight is being blocked. So this won't turn off the stars, but it dims them. So if I do this, and I'm trying to figure out which one of those bright star-looking things would be the planetary, I can do this, and you'll see one of them stays pretty constant in its brightness and the others dim. And that's how I figure out which one's the planetary. Another thing I've been known to do is to look at the Veil Nebula or something fairly large. And I'll do the same thing, but I'll use a different filter. I'll use the UHC filter, and I'll have a fairly wide eyepiece, and I'll be looking with no filtration. And I try to study exactly how it looks, where the structure is in the picture, and then I'll flash the UHC in and see what effect. And that way I can decide, is it helping or not? What part of the nebula is it helping? What more am I seeing? So I do that. The other thing I do, especially with the larger telescope, is if I feel like there's more to be seen than I am able to see, I'll jack up the magnification a little bit, because that's kind of darkening the view to me, and it seems more contrasty. Now, that's a thing that probably works for some and not for others. So really you need to decide out of these techniques which ones are benefiting you and which ones are a big fat waste of time, and go with what works. The key here is to experiment. If you don't own the filters and I know this question is coming, you don't own a filter and you wonder which one should you invest in first. I think I would ask, what is it that you want to see? What kind of object appeals to you? Well, everything. I want to see everything. Okay. How big is your telescope? Well, it's 8 inches. It's 6 inches. Okay. I would recommend a UHC filter to start with, because it can be used on a larger number of objects. And it's not such a strong filter that you just can't use it very often, unless you're in a really dark place with a really big telescope. So that's what I would recommend. And if we ever get to go observing again, maybe you can borrow a filter and see for yourself which one works well for you. Any questions?
There are some in the chat, Phyllis.
Yep. Hey, I can see the chat. Filtering LED requirement for IDA. I don't think it is a requirement. When that can be a requirement. When a park or a property applies to the IDA to be a dark sky park or whatever status of darkness they're trying to gain, they need to, Jim may actually know what the Stanton River Park did. Do you know?
Well, they had to go through a bunch of readings using a sky quality meter, and they literally have one on the roof of the building, or a sensor checking it all the time. And they get different levels of qualification. Like there's a gold status and a silver. They're at silver, I think. And the bottom line answer to Rob's question is no light is what they want to see. There wouldn't be any kind of light that would help us get any darker. So the LED thing is a problem here in the cities, and hopefully you won't find any around the state park anyway.
But there's no filtering required. The park is going to limit the lighting in the park.
There can be shading. They're like, I've forgotten what they're called, but they're like
full cutoff fixtures.
Yeah.
Right. I mean, so it directs all the light downward. So all you're getting is reflected light instead of light coming out from the sides.
Instead of being able to read a book, right?
Yeah. But I remember Jamie talked about this, and I remember him saying that the idea behind the IDA is that if you get that classification, then you've got leverage against, politicians and policymakers have leverage against zoning to prevent businesses from putting in bright lights. And I think they actually, Jim, was it the Hardee's or was it a car lot?
Well, I don't know which one, but they are able to generate a little bit of pressure in the surrounding community because they have gotten dark sky status.
Right.
And several places now will try to cooperate and lower the lights or put on full cutoff. Just means something that keeps the light down and doesn't let it just go to the sky. And so we're working on it, but this has been a thing that's being worked on for 25 or 30 years now.
Well, he said
but the Virginia parks are all trying to get that status in their areas because they've suddenly realized that's another use for the parks, and that's actually spreading out into the community. So it's a very positive situation, but it's moving rather slowly.
I'm afraid I'm not surprised, but at least it's moving.
Cheap LED lighting is really working against us because now it's really inexpensive to light stuff up. Nobody thinks twice about it now.
All right, well, let me move on to the next question because I like that question. How do I find out what deep sky object emits? Well, I don't know how to answer that simply.
Web search.
I mean, it's in most of the descriptions. It's either going to be a reflection nebula or an emission nebula. And
Well, you're not going to have to look them up one at a time. Just through the years, whenever I'm on cloudy nights or do a search on deep sky objects or some version of any wording you could choose, you will come across lists of probably 30 to 100 deep sky objects with the filter designation next to them, and they will have done surveys. And they'll say, we like the UHC on this object, and we like the oxygen 3 on that one. And every once in a while on this 1 or 2 objects, you can use an H beta filter. So it's already done, and you just print the list out and take it out observing. And there it
Stellarium
is.
has that. That's what I was talking about. Stellarium has recommendations for eyepieces and for filters, and it has, if you allow in the settings, it has really elaborate descriptions of the objects, and it classifies them if they're emission nebula or if they're reflection. And if they're emission, then it usually tells what the primary source is.
Yeah, for clarity, reflection nebula just means there's a star nearby that's lighting up this gaseous nebulous area, and the filter won't help you with that because you're blocking white light that's bouncing off the nebula. The filters we're talking about help you with something that's emitting light in a very specific wavelength.
Yeah, is Rob still there?
Yeah, he's here.
Yeah.
Okay, well, my answer would be a little different from theirs in that if you read, I don't know, if you read the astronomy magazines, if you've taken astronomy courses, you learned about the different physical processes that occur inside different types of objects. And that tells me what kind of light to be looking for. And if you need something a little more easy, a little easier guidance, anything that is stars, like clusters or single stars, they're going to emit light in all colors. It's a continuum. And galaxies are going to do that too. When we get to these nebulous things like a planetary nebula or an emission nebula or a reflection nebula, they are a little different. Planetary nebula has an unusual physical process that allows us to see oxygen 3. This is a forbidden line. You can't make it in a laboratory. So we realized at some point that that special emission line that we're seeing in the spectrum of these funny looking planetary nebulae is being created by a cosmic process that you can't even do on Earth. So we know that we can see oxygen 3 coming from a planetary nebula. We know that we can see hydrogen alpha and hydrogen beta being emitted by a diffuse nebula. And like somebody just said, it might have been Jim, somebody just said about the reflection nebula. The light from a star is being reflected from the dust nearby in space. So the physical processes that cause these emissions sort of defines somewhat the class of object and therefore the type of filter. If you go out on the observing field, you're probably not going to find anybody using an oxygen 3 filter looking for galaxies because it doesn't make sense. But if you try it a time or two, you'll find out it doesn't work. So here again, you just need to try various things. Dark sky legislation, yes. You know, light pollution and dark sky legislation, that's a whole other topic. Maybe I should work on that. Any other questions?
Yes, for Phyllis and for Jim, because I guess I've talked to Jim about this. filter manufacturers? Do you have favorite ones? Number one. Number two, what about the binocular viewers that Jim and I talked about filters for those? You need one filter, two filters, the same filter? Any ideas about that?
I've had very good experience with Lumicon filters. There is a vendor out in California that I have discussed this very issue with, because I haven't bought a new UHC filter in 30 years. So I wondered how current products stacked up. And he thought that the Lumicon brand and the Teleview brands were the best.
Still, even 35 years later.
Well, yeah, so maybe I got lucky for once. I was looking for a 2-inch oxygen 3 filter, and that was his specific recommendation for oxygen 3. Yeah. So that was the first answer. What was the second question?
Using binocular viewers.
I've never been able to be a binocular viewer person. I've got eye muscle troubles. However, years ago, I was at the Winter Star Party and somebody handed me a pair of Fujinon 8x50 binoculars. And they said, look up there at Gemini and see what you see. So I looked, and there were UHC filters on the eyepieces of the binoculars. And I could see all kinds of nebulosity, and I just totally flipped out. I had never thought of putting filters on binoculars. But of course, if they're threaded eyepieces, you can do it. So to answer your question, I don't know whether you can buy a filter that would fit the nose piece on bino viewers.
You can on modern ones.
Okay. Well, I'd rather buy one big filter than two small ones, I think.
Well, you could screw the bigger filter onto the bottom of the focuser in most cases, and then just put the binoculars in normally. So you wouldn't have to have two. There's a caveat I would mention here. I held this up for a reason, whichever way is correct. I have some of the original Teleview bandmates, which I was happy with, but you will now see, and you need to make a distinction, they now sell Teleview bandmates type 2. Right. And the original ones have gone away. And there was a little discussion on Cloudy Nights where they said the cutoffs for the original bandmates were too wide. In other words, instead of being virtually just a straight up and down line, they actually kind of came in a bell shape. And so some people argued that aesthetically they preferred the original type, especially with smaller aperture refractors, because you could actually see stars and locate yourself. But the purists who wanted to see only the nebulous images wanted a very tight fit with just the nebula coming through. So the current type 2 power mates from Teleview are very narrow band. I think they're made by the German company Astrodon or somebody.
Astronomic.
Okay. So they're much tighter. So that's something to consider. If you're buying a used filter, be sure you know whether it's type 1 or type 2. The type 1s work, they just work differently. And it depends on whether you're a nebula person primarily or whether you're an aesthetic viewer who just wants to get the whole picture. There's never a simple answer in astronomy.
No, that brings up a point. It used to be true, and I don't know whether it is now, but it used to be true that a manufacturer such as Lumicon would get a lot of filters in, and the transmission percentages would vary. So the filters that allowed a lot of the specific wavelengths that you want would be a premier lot. And they would get another lot that was slightly lower percentages of the specific wavelengths. So they would be cheaper, but the premium ones would be more expensive because they were harder to make. And they do have to test these things in order to make sure that they pass QA. So you might look for that too if you want to get that persnickety for a premium lot versus a standard lot. Many years ago, one of our club members had access to a lab out at RTP, and he took my filters and tested them on his spectrometer, I guess. He found that the statistics written on the back of the box, can you see that?
Yeah.
He found they were true. They were accurate. So that surprised me. At any rate.
Let me mention one other thing about that. You and I both have the Lumicons that go back over some decades. And the original way they did it was sandwich the coating between two pieces of glass. And there are some issues with that. So here is a premium. And it's like Phyllis said, I can't focus that close, I guess, but they would list the wavelength and then the percentage of transmission. And this one was saying 97.9, 98.7. So it's the premium Lumicon UHC. The trouble is over time.
Yep. Uh-oh, he froze.
That 97 and 98 has probably come down some. And my expectation is now filters cost even more relatively than it did then. And the new ones apparently are able to deliver the numbers accurately and keep them longer because they're actually plated onto the glass and won't fade the way the old ones do.
I discussed this with the Lumicon sales dude at NEAF one year, maybe the last time I was there. And they said that if I sent my filters to them, they would test them and see whether they needed to be replaced or
It would be an
whatnot.
interesting test, Phyllis. Let's see.
The guy never wrote me back email, so I didn't do it. But they said they would offer that service. But you're right, Jim. You and I are the only ones on the planet that have these 30-year-old filters. Are there any more questions?
Phyllis, I had just a quick one about the blink technique.
Yes.
Which is cool. I like it. After you've done your blink technique, do you then select that filter if you turned out that it was working fairly well, or you just continue just to do your blink?
Sorry.
So do you actually end up screwing it onto the eyepiece after you've done your blink, or do you just sort of use it?
Just leave it in my fingers and
Okay.
look at it.
Okay.
If I decide I want a long view, I really want to study, then I'll take the eyepiece out and screw it back in. But my Dob, I use a Dob. It is not driven. So depending on how much power I'm using, if I have to take the eyepiece out of the focuser, screw the filter back in and put it back in, a lot of times the thing's
It's out of the view. Yeah.
So if you had a driven mount, I would probably be more apt to screw the filter in. The other thing that we know some people do is they have a filter with all the filters mounted on a sliding drawer kind of thing. And Jim can tell me how he uses this, but I think this is a way that you can change the filter per view instantly. Jim?
Oh, yeah. Well, did you get the email I sent this afternoon? Okay. Yeah, they make these sliding devices, and Dave there suggested a rotating one. And I think for the imagers, they're often circular so they can take up less space. But in the upper cages of the big Dobbs, we just have a long slide. And in fact, they often have a heating element running around them so they won't fog up. And you can open it up so there's no filter and then shove it in place and get whichever kind of filter you want just to see what will happen. But one problem I would point out, if you're looking through it blinking, Phyllis is right. That's a way to pick out which is the planetary nebula if it's in there. But you have to be careful because if your eye gets very far away from the filter, you're not only getting the light through the filter, you're getting light above you if you're out at big woods where there's lots of light. And so that's actually going to hurt you. You'd almost have to do the towel over the head to keep the top light from getting into it. So, there's ways around any problem, but
there's one other thing too. If you use that blink method,
I would screw it on if I were going to look at it for any period of time.
right. So if you have your filter and your eyepiece, you really want that filter to be parallel with the top of the eyepiece, because it's an interference filter, and if you cock it, it doesn't do what it's supposed to do.
You can actually tune it a little bit. It shifts the wavelength up and down the spectrum just slightly if you tip it.
Yeah, but that's a thing to remember.
We don't recommend that.
Not very reproducible results.
I was going to say in favor of the blink technique, there's been a lot of times where I've had my filter in, observing something for a long time, and then I slew over to another object, and all of a sudden I was like, why is this so black? Only to realize, oh well, yeah, I've left my filter in. So it's a lot easier if you can just kind of get used to putting that filter in front of your eyepiece and just studying it that way. Then, again, unless you're going to do something like, I don't know, if you're looking at the moon, you're trying to sketch or something like that, then that would be an instance where you'd keep your filter in longer. But I've done that plenty of times only to realize that, oh,
Yep.
Yeah.
Say another thing about lunar observing is a lot of times people will reduce the amount of light coming in their telescope with a mask as opposed to filtering what they're looking at. So you can actually buy a mask that has a tiny hole in it, and it takes the 10-inch and cuts it down to a 4-inch. And that lowers the amount of light coming in, which makes it easier to look at the moon. My light bridge, if you look at the full moon on a clear night, it will blind you. You absolutely cannot. It's almost, it's not like looking at the sun, but it's painful. And so you have to do something to cut the light down. And I actually have a mask I can put on it that takes it down to about 40%, somewhere between 35 and 40% of what the full diameter is.
Yeah, my little Orion actually came with the cap. It has a little cap you pop off, and it works beautifully for that as well.
Yeah.
Well, you're changing the whole system from maybe f8 to f20, so you're giving away resolution.
Yes,
but and so darkening the background will make things stand out better.
Yeah,
right.
That's a poor person's filter, just darken down the background.
Yeah,
and you can do the same way by going with a little bit more magnification. That will darken the background also.
Yeah.
So a nice tool to have in your lunar filter would be something like this, which is basically a double ring filter. So as you turn the ring, you actually literally, you see how that went black there, and you can use this. You can even use this almost on a full moon, and pretty well get some decent contrast off of it.
Doug brought that to the stargazing party, and it was incredible.
Yeah,
how it shut it down. Polarizing filter. Yes.
Yeah, and you can buy those as a unit so that you dial like Doug's showing. But the other way, if you happen to have a 2-inch size polarizing filter, screw it on the bottom of your focuser. Most of us can do that probably. And then you screw a smaller filter, polarizing filter onto your eyepiece, and then you can just rotate the eyepiece, and you can control how much polarization you get.
Yeah, that's a great idea. That's a really good idea, Jim. I hadn't thought.
Well,
I
didn't think of it. Somebody pointed it out to me. So.
Yeah, that's a great idea.
I have one little commercial. This is the Moon and Sky Glow filter. I'll figure out which way to turn it. Well, it's the wrong way. Anyway, Moon and Sky Glow filter is just faintly purplish looking, but not too much. And when you use it on, it's knocking down the sky glow, the same as we mentioned earlier with the deep sky filter, or the nebula filter kind of thing. But it also seems to boost the contrast on like the bands on Jupiter and a little bit of detail on Mars. So without hurting it, it doesn't make it look garishly orange or messed up. So I actually like the Moon and Sky Glow. I think that's a Batter product, Bader. But I have that and use it maybe more than the others because I don't like a lot of color if it's not helping with something. But it will pop out some of the detail on Jupiter.
Any other questions? Yeah.
I was going to ask, is that similar, Jim, to the sky glow filter that you would get, say, like on the old cameras? They used to basically, you could buy a sky glow filter for your camera.
That was probably more of a to knock down the blue in the sky. You know, when you're looking in the Blue Ridge Mountains, they look extremely blue unless you put it's a faint pink color, and they're called skylight filters.
Yeah.
And they're just filtering the blue of the sky and the haze that used to, in the old days, bring the film back to what you saw naturally. And we used them as protection. So if you dropped your camera, it fell on the filter and you could replace that.
Yeah, a lot
better.
easier than you could be able.
But yeah, this is a little different. It produces a little more noticeable color, but what we were trying it out the other night on Jupiter, and you really could see the bands better.
Wow.
So I'm not sure what the trick is, but this one doesn't. It's a more modern filter, and it wouldn't fade out over time. So I don't know. It's tricky, like Doug said. We went from something over to look at Mars, and it was fiercely red, and we were admiring how much redder it was in one of the guy's telescopes than it was in mine until we realized he still had the red filter screwed on the eyepiece. And once he took that off, it was much more similar to my telescope again. It's pretty easy to forget you've got these things in there. Phyllis has never done that.
Blink, blink, blink.
Never. Never. All right. Well, so with that, I guess we're done.
Thanks, Phyllis.
Good night, Phyllis, and thank you.